Let us start with lesson number 2, interior of the earth. Now let us first understand what lies in the earth's crust. Okay. Now let us take an example to study this. Now my dear students, before boiling, the milk was in liquid state. Now after it comes to a boil, the steam started coming out from it. Now after some time, a thick layer of cream develops over the milk. The temperature of the cream is lesser than the milk below, right? Thus, it can be implied that the creamy layer has cooled faster than the milk below it, now which remained hot and is also in liquid form. A similar process occurred in nature, my dear. Okay. Now, the scientists unanimously believe that the earth was formed out of the solar system itself. Initially, earth was a gaseous hot balloon, right? Then it cooled down as it rotated around itself. The process of cooling took place from the outer surface towards the Earth's center. Now, as a result, the outer layer of the Earth became cooler first and solid. But as we move from the outer surface to the core, the heat increases at certain depth and the interior of the Earth still remained in semi-liquid. Okay, man has always been inquisitive about what lies in the interior of the earth. Okay, a direct observation of Earth's interior has not been possible as yet. So, through various methods, the scientists even tried to estimate actually what lies below the earth, to infer these, study of material which are coming out of volcanic eruptions, and the seismic waves is most important. My dear students, now through the estimates of the study of the temperature, density, gravitational force and pressure, the interior of the earth was understood. Now for instance, when we go down deep into the mine, we feel an increase in temperature. Similarly, the magma which is coming out of volcanoes from the earth's interior is also hot, right? Such estimates were made by the geologists. Several earthquakes occur in various places on the earth every year. Now, seismic waves are generated. These waves travel through the interior of the earth. The study of their direction and velocity helps us to estimate about the interior of the earth. Now, the man also has tried to dig boreholes into the interior to know more about the inside. Our earth was formed approximately 4.6 billion years ago. Initially, the earth was in gaseous state. Then it started cooling through the process of radiations. The earth then liquefied. Now with time, the outermost part of the earth cooled first and became solid. Then this outermost layer of the earth, we call it as crust. Even today, other planets of the solar system are still in gaseous form. Okay. Now, so we are going to divide the layers of the interior of the earth into three. That is crust. Crust are further divided into continental crust, oceanic crust. Mantle is the second layer which is further divided into outer and inner. And core is again divided into the outer core. And let us see in detail what is there in the interior of the earth. Okay, now inside of the earth, let me tell you, my dear students, that the characteristics of the material which is found from the surface to the center of the earth, it is not same. It vary considerably. Okay, now the crust, the mantle and the core, these are the three parts, or we can say like three divisions of the interior of the earth. Now, the first layer, we call it as the outermost layer, is formed of solid rocks, and these solid rocks layer we call it as crust. Okay, now this solid rock layer is called as crust. Now below crust is the next division, that is called as mantle. Okay, now the crust and the small portion of the mantle adjacent to it together are called as lithosphere. Now, let me tell you, this is what you can see, the portion, the crust and a small portion of the mantle which is very close to it, which is adjacent to it, is together called as lithosphere. Now the lithosphere, my dear student, is about 100 kilometer thick. Now the lithosphere is in solid outer part of the earth. Lithosphere includes the brittle upper portion of the mantle as well as of the crust, the outermost layer of the earth's structure. Now all of the rocks on the earth from the mountain to the sea floor is included in the lithosphere. Okay. Now let us see the third division. Now the division which is below the mantle is called as a core. What it is called as a core. Now core is further divided. It is divided into the outer core as well as in the inner core. Okay. Right. Now the outer core is always in liquid state while the inner core is in solid state. Now let us see these three layers, what I said about the crust as well as the mantle as well as the core. Let us see in detail of each of this. That is, first we will see the first layer, which is very thin. Now this layer is of solid material, but it is very thin. Okay, what is that outermost layer called as? It is called as a crust. Now its thickness is about 30 to 35 kilometers. And you can see it is as thin as how the layer or how the skin of the apple is. That way it is very thin. And inside how the density of the apple is, it's like that. Okay, it is made up of the lightest material. Okay, now crust is further being divided into two parts, which is called as the oceanic crust as well as the continental crust. Now oceanic crust means a thin layer of the crust that overlies, or we can say like overlies the ocean floor or ocean basins, is called as oceanic crust. Now more dense than the continental crust it is. Now mostly basalt rock is found here. Now it is thinner than the continental crust. It is almost 5 to 10 kilometers. It is younger, or we call it as newer than the continental crust. Continental crust. Now continental crust, we can say it's a layer of the rock which forms the continental crust, the continent. Now less dense the oceanic crust. Now mostly it is made up of granite kind of rocks are available in this layer. Then it is thicker than the oceanic crust and older than the oceanic crust. Okay. Then we will see further the next division. The next division is called as mantle. Now this mantle is a layer which is exactly below the crust. Now the mantle is the largest layer of the earth and very active. It is one of the active layer we call is of the earth. Okay. Now why we call it as an active layer, and let me tell you, it is also the largest layer of the earth. Now solid rock layer between the crust and the core, the middle part of the earth interior. Okay. Now let us see in detail about the mantle. Mantle is further divided into the upper mantle as well as the lower mantle. The mantle, we can say like upper mantle means the top section of the mantle, but let me tell you, it is in solid, so it is made up of solid rocks, top upper sections, then that comes under the as well as lithosphere. Right. Now the rest of the upper portion of the mantle is what is in the melted form. Okay. The upper mantle, only first layer of the upper mantle is in solid, which is a part of lithosphere, and the rest is what it is in the melted form. Clear. Most of the rocks here are melted due to extreme heat. Then below that is the lower mantle. The lower mantle is in solid form again. Let us see in detail about it, that about the upper mantle. Now the upper mantle begins just beneath the crust, ends at the lower mantle. Okay. Now the thickness of the upper mantle is around 200 to 250 miles. Got it? Now very importantly, the upper mantle is more in liquid state, as I said, and you can find here magma chambers. You can see here magma chambers where in the upper sections, and it is through these magma chambers that the volcano which comes and volcanic eruption takes place to the surface of the earth. Now this is the layer, let me tell you, this layer where the magma chambers are called as asthenosphere. Okay, the layer where the magma chambers are in mantle is called as asthenomosphere. Okay, now this asthenomosphere is highly viscous, mechanically weak, and ductile. And this is the region of the upper mantle of the earth. Now it lies below the lithosphere and at a depth between around 80 to 200 kilometers from the surface. Then let me tell you, this is a section where almost every activity takes place. For example, epicenter. Okay, epicenter of the earth lies here in mantle. Okay, mantle begins at a depth of around 42 kilometers from the earth's surface. Okay, the internal energy which is released due to the endogenetic movement occurring in this layer is responsible for this all. Okay, from the mantle, the energy which is released is responsible for mountain building, or is responsible for rift making, is responsible for volcanic eruption, and are also responsible for the earthquakes which takes place on the surface. Okay, now we should not forget this, that is called as convectional currents. The middle mantle flows, okay, because of the convectional currents, the center, okay, of the mantle, it flows because of the convectional currents. These convectional currents are caused by the very hot material of the deepest part of the mantle rising, then cooling, then sinking again repeatedly, and this cycle goes on continuously. You can see I have shown it in the red color circle. Okay, what that circle tells you that the hottest material comes up, cool, goes down. Again, the hot material comes up, cool, goes down. That circle continuously goes on, and this is called as convectional currents. What are they called as? Convectional currents. Okay, let us move for the next one, that is the lower mantle. Now the lower mantle extends from about 660 kilometers, that is 410 miles, to about 2700 kilometers. Okay, beneath the earth's surface. The lower mantle is hotter, it is denser than the upper one. Upper one is in liquid state, right? The lower one is in denser, that is, it is in solid state. Clear? Then let me tell you, the low mantle is much more, or we can say like it is less ductile than the upper mantle. Although heat usually corresponds to softening rocks, intense pressure, okay, keeps the lower mantle in the solid form. It is having a lot of pressure from above layers from the crust and the upper mantle, and so the lower mantle is in solid form. Okay, now let us go for the next one, which is called as a core. Now the central, or we can say like innermost portion of the earth which is lying below the mantle is called as the core. Now the core starts from around the depth of 2900 kilometers from the earth's surface, and the part of the earth's interior extending up, that is from the mantle up to the center of the earth, is the core. The thickness of the core is around 3471 kilometer, and this layer, or we can say, can be divided into two. Core can be divided into two division, and the two division of the core is inner core and the outer core. Okay, now let us see the first one, which is called as an outer core. Very much you should pay attention to this. This is very important from exam point of view. Okay, now let us move to the outer core. My dear students, the outer core, it extends from 2900 kilometers to 5100 kilometer. Okay, the secondary waves cannot pass through the core. Secondary waves means these are the waves which are responsible for, or which are generated in the mantle. Now the waves which are generated in a mantle passes everywhere, but it cannot pass through this. Okay, they get absorbed in the outer sections. Okay, now this has led to the scientists to believe that the core could be either liquid or semi-liquid in nature. Clear? As the waves are getting absorbed, so the scientists believe that this layer of the core is either it is in liquid or it is in semi-liquid in nature. The primary waves, they travel through this layer, but their speed reduces when passing through this layer, and the density of the outer core is 9.8 gram per cubic centimeter. The temperature of the liquid outer core is around 5000 degrees Celsius, which is almost the temperature of the sun. Okay, the outer core, as I said, is the third layer of the earth. It is only in liquid form and is mainly made up of metals of iron and nickel. Now it's roughly extent from 2900 to 5100 kilometer. The outer core is responsible for Earth's magnetic field. Okay, now what is this Earth's magnetic field? Let us see in detail about it. Now, Earth's magnetic field, my dear students, when we learned that the outer core of the Earth's interior is in liquid state and the proportion of iron is more in this layer. Let me tell you, my dear students, iron is more in this layer. Vertical currents originate in this liquid layer, and this is another characteristics of this area. The difference, when there's a difference between the temperatures of the outer and the inner core, which gives rise to vertical currents. The Earth's rotation gives them eddy circular motion. Okay, you can see how is the motion of those blue color or yellow color or purple color lines. How it is eddy. Eddy means circular. Okay, now electric currents develop in these spiral eddies of liquid iron, and thus magnetic field is generated. See, natural magnetic field is generated, and it is sometimes called as geodynamo. What it is called as? It is called as geodynamo too. Now this magnetic field of the earth is functional even outside the earth's surface. It's not like that this magnetic field is created only inside the earth. No, it's functional, means its effect you can see even outside. Okay, as a result of this, you can see like as a result the cover is developed around the earth because of this magnetic field, and the earth's atmosphere is protected from the sun's solar winds coming from the sun. Okay, now the magnetic field thus developed around the earth is called as magnetosphere. What it is called as? Magnetosphere, and this is the fifth and an important sphere of the earth. Very important, students. The earth's magnetic field is generated by slowly moving liquid part of the iron core. Now earth has a north pole and a south magnetic pole. It traps many charged particles from the sun, which protects us from harmful solar radiations. Very important. Okay, the internal core is very important, right? Now let us see about the next one, that is the inner core. Now the inner core is extended from around 5150 kilometer to the depth of around 6371 kilometers till the earth's center. It is the core of the earth which is in solid state. See, I'm talking about what? That outside the crust is solid. Okay, inside the first layer, or we can say like the upper layer of the mantle is in liquid. Again, the lower layer of the mantle is in solid. Again, the upper layer of the core is in liquid, and now you can see the inner layer of the core is in solid. Means solid, liquid, solid, liquid, solid. Okay, this is the condition, right? The density of the sphere, here I'm talking about the inner core. The density of this sphere is around 13.3 gram per cubic centimeter. Iron and nickel are the major elements you can see here in this inner core. Okay, inner core has iron as well as nickel as a major components, major elements, and so this layer is also called as neef. It is also called as neef. Now as the material in this layer are under extreme pressure, they are under extreme pressure. What kind of pressures? Now it has many layers above, na? Like the crust, then the upper crust, upper mantle, lower mantle, Okay, then again the upper core, all these different layers are creating or exerting pressure on this inner core, and so you can see the temperature here is almost so high that it is equivalent to the surface temperature of the sun. Okay, now we should not forget this, my dear students. What is this? Let me tell you, as I told you about the layers, right? What are the layers? Let us repeat those layers. Layers are the crust. Okay, they are the crust, the upper mantle, the outer core, the inner core, right? These are the layers, right? Okay, now we all know that these are the layers, but let me tell you, all these layers also have some gaps in them. There is a discontinuity between the continental crust and the oceanic crust. Now it was first being deduced by a scientist called as Conrad, and is named after him, called as Conrad discontinuity. Now there is discontinuity between the crust and the mantle. Okay, and this discontinuity was deduced by a scientist which is called as Mohorovicic. Okay, and it is by his name that discontinuity is been called as Moho discontinuity. There is discontinuity between the mantle and the core. Now it has been named after Gutenberg, a scientist who discovered it. And so you can see the discontinuities are named differently. I repeat again, the discontinuity which is between the continental crust and the oceanic crust, that is called as Conrad discontinuity. The discontinuity which is between the crust and the mantle, that discontinuity is discovered by Mohorovicic, so it is called as Moho discontinuity. Okay, then there's a discontinuity between mantle and a core, and this discontinuity was discovered by Gutenberg, and so it has been called as Gutenberg discontinuity. Okay, yes, again lemon was the one who found out the discontinuity between the outer core and the inner core. Okay, right? And so from this it is very clear that inside of the earth is not stable, my dear student. It is not stable. There is constantly changes which takes place inside of the earth. Okay, and so from this it is very clear that the inside of the earth is not stable. It is not stable. Thank you. The image which is given on page number 14 of your textbook. Now let us see here what is given in this image is there. You can see there are two graphs, and we are going to read this two graph. Okay, it is figure number A. That is, you can see the left curve. See the left curve in figure A shows the velocity of secondary waves. It shows the speed of the secondary waves, while the curve on the right shows the primary. You can see the curve which is there to the right shows the primary waves. There are many changes occurring in the curve of the secondary waves. Now the curve drawn with the help of dots shows the average velocity of the waves. The curve of the secondary wave seems to have ended around the depth of 2900 kilometer. Secondary waves are ending there, that is around 2900 kilometer. Changes are visible even in the curves of the primary waves. Now here the primary waves, they get divert. Okay, they change their direction. Right, now the velocity of the primary wave increases according to the depth till 2900 kilometer, but the velocity of the secondary waves is around 6 to 8 kilometer per second. Okay, around the borders of the outer core, and the curve has stopped there. Now these waves do not enter the core. Okay, the secondary waves do not enter the core. Okay, at 2900 kilometer the velocity is around 12 kilometers per second, but when it enters the core the velocity reduces to 8 kilometer per second. See this as shown in the dot curve. On the basis of these curves, the scientists have inferred the densities of various depths. From this it is very clear. Okay, from this it is very clear what, that as you go deep inside, or as these waves are going deep inside, I told you surface the secondary and the primary waves travel through all. Okay, but secondary waves cannot go into the core, right? Core, if it is reaching the core, it get absorbed there. Got it? Right. Now from these waves it is very clear, from this graph it is very clear, the density curve of the earth's interior as shown in B1. You can see the B1 now, red curve. See the red curve there in the figure B, which shows gravitational force. See the level of the gravitational force at depth. See the depth also. As the depth increases, gravitational force, you can see the structure of the gravitational force. At a greater height it is greater, at a less height it is lesser, you can see. Okay, gravitational forces increases at certain depth from the surface and then reduces according to depth. At the center it is zero as it is visible from the curve, right? Yes, now observe these figures minutely and find out where these discontinuities in the density curves are. Clear? You will see this carefully. Now at home, what textbook you have, you will go through this textbook of geography and you will see regarding the discontinuities. You will see in detail what I said about these curves. Okay, you should see these all lines you can see are the primary waves and the secondary waves. Again, I am repeating, primary waves and the secondary waves are those waves which are generated from mantle. Okay, mantle, there are radioactive elements. These radioactive elements generate energy. They release energy and this energy moves inside the earth in the form of waves. And these energy waves are being divided into primary, secondary and surface. Okay, inside you can see primary and secondary which are moving. Okay, right? And thank you. Have a nice day.